Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
So after we confirm that the preamp circuitry of this unit, it is working like it should be and there is no problem in it except dirty controls, I unplug the power cord of this unit and I also disconnect the probes of my test unit in order so I can turn the unit around and do a visual inspection of the parts and the component in the power amplifier circuitry, and to see if there is any faulty or corroded component in these two circuitry. And after a thorough examination, I found several mistakes and several problems has been done in these two circuitry. And I will start by counting the problems one by one. The first problem that I found, that whoever work and repair these two power amplifier circuitry, he replaced the transistors with a different transistor part number. So if we just zoom in a little bit, we can see that this transistor, it has the number of C3855, and according to the manual or the schematic, this is the correct part number that it is listed in the schematic. But we can see that whoever replaced these transistors, he did not replace them with the same part number. He used an equivalent, and this equivalent, it has a different specs than this one. So yeah, this is what happened to this circuitry or to this amplifier, and the same thing he did with this amplifier as well. Now the second thing that he did, he replaced the photocopier IC, and according to the manual or the schematic, this circuitry uses a the TLP 521-2. It is basically a photocopier IC, a dual photocopier IC in the same packaging, but as we can see, he replaced it with a single one, and he replaced it with the normal photocopier IC. It is the PC 817. And if we flip the camera and zoom in, we can see that this is the part that he used. So yeah, now I don't know if this IC, it is the equivalent of the original TLP 521, but I will have to look into it. So yeah, now when I examine the pins of the some of the transistors, I found that some of the transistors, like this guy over here and around it, there is a lot of corrosion in them. So yeah, and not only that, whoever worked on this amplifier, he replace and manipulate the value of some of the resistors in the input circuitry. So yeah, wow, this is really weird type of repair. So what I'm going to do next, I will see if I can get access to the other side of the PC board and inspect the traces and see what kind of work has been done to these PC board. Now, the cool thing about this model that it has an access cover in the bottom of the unit, and it is held to the body of the unit by these screws from 3 corners, as you can see. So what I'm going to do now, I'm going to remove all of these screws, remove the cover, and take a look at the PCB of the power amplifier. So here is the access cover has been removed, and after I remove it, we can view and we can examine the main PCB board that hold the signal input selector IC, and also the signal control switch, and also the preamp or half of the preamp circuitry, and also the regulator voltage regulator circuitry, and also the power amplifier circuitry. Now, if we examine this section of the PC board, we can see that it is in a really good neck, and it is the pads and the circuitry in it, it is very clean. Now, I repaired this from a long time ago. As I said, it is about 10 years if I wasn't mistaken, and it is still in a really good condition, as we can see. And here is the regulator circuit that I work on in the past, and it is still in a really good condition as I left it. But if we take a look at the power amplifier circuitry, we can see the amount of damage that it is occurred in it from the sloppy job and the unprofessional job that whoever worked on this, he did it. So yeah. So if we examine the traces, we can see a lot of peeled and removed or missing traces, a lot of scratching in the PCB itself, and a very sloppy soldering job. So yeah. So repairing this amplifier, it is going to be a very hard task, and especially in this kind of damage. So what I'm going to do next, I believe I will start the testing process by removing and testing all of the component in the power amplifier circuitry, and I will test all of the transistors, all of the component individually, and we will go from there. So I removed and disconnect all of the components from their places in the PC board in order so I can test each one of them individually. And after I performed the necessary testing, I found that all of these components, they are still working fine, but these components, from the other hand, they are faulty and needed to be replaced. As for the replacement resistors, and according to the resistance value they are listed in the schematic, I found that these resistors, they have the right value and they are belong into the amplifier circuitry, but these, they don't belong into the amplifier circuitry. So yeah, so whoever worked on this unit, he put these wrong values in it. So yeah. So as you can see, there is a lot of work needed to be done in order so I can make this amplifier work in the correct way again. So yeah. So what I'm going to do now, I'm going to contact the owner and brief him in the situation that his amplifier, it is in it, and see what type of work he wants me to do in order so I can repair his unit. So I talked to the owner and I informed him about the condition of his unit, and I told him in order so I could repair it that there is 2 types of work that I could do for him. The first type of work that I also recommended, it was a complete restoration. The second type of work that I told him about, I could just make it work correctly. And I told him about the cost of the two types of work. And he informed me that he doesn't have a budget for a complete restoration of this unit. So we agreed that I will repair it just so it can work correctly. So what I'm going to do now, I'm going to replace all of the faulty component and reinstall all of the good ones, and we will see how this unit is going to work. So here is the unit has been completely repaired, and in order so I can repair it correctly, there were a number of steps that I did, and now I'm going to tell you about each one of these steps one by one. Now the first step in the repairing process, it was readjusting the regulated voltage from the regulator circuitry. Now I started by testing all of the component in the regulator circuitry, and the test shows that the two Zainers, they were underneath these resistors in here. They were a little bit leaky. So after I replaced them and replaced all of the capacitors in the regulator circuitry, all of the voltages are back within the normal values like it is mentioned in the schematic. Now the next step in the repairing process, it was in the amplifier circuitry. And if I just turn the unit around, I can show you the steps that I did. So here we go. As we can see, all of the parts in the amplifier circuitry has been installed. And I started by installing all of the resistors into their places, and according to the values they were listed in the schematic. After I done the resistors, I installed all of the transistors into their places, and according to the part numbers they were listed in the schematic. After I done the transistors, I replaced all of the capacitors with the brand new ones. After the capacitors, I started installing and testing all of the component in the biasing circuitry. I downloaded the specs or the datasheet for the PC 817 that whoever worked in this unit, he installed it instead of the TLP 521, and the specs showed that the PC 817, it doesn't serve as a substitution of the TLP 521. Now, lucky for me, after some search, I was able to get the original TLP 521 from a supplier that I buy parts from. So after I installed the original TLP 521 and I started testing the biasing circuitry, I found something really interesting. And that is in the VR resistors that control the biasing current. Now, the original pots, after I tested them using the VOM meter, the test shows that the pots are okay. But after I install them and I energize the circuit, the test shows that the VR resistors, or the original one, they have a blind spots and the carbon wafers in them. So I replaced them with these multi-turn pots, and to be honest, these multi-turn pots, they are very suitable to this type of circuit. So after I done the biasing circuitry, I installed the driver transistors, a matching pair for each channel, and here is the new power transistors. Matched pair of power transistors has been installed in every amplifier circuitry. Now the third step in the repairing process, it was testing all of the component in this board. Now this board, it is the main power supply board slash speaker output board. I started testing all of the component using the VOM and the DMM multimeters, and I tested all of the filter capacitors using the capacitor meter, and the test shows that all of these components, they are still working perfectly. As for the relay that it was installed in this board, I tested it using the VOM, and when I tested it, the test shows that one of the contacts inside of it, it was faulty. So I replaced it with this Chinese high quality relay. Now after I done all of this, I tested the board separately, and the test shows that the board, it is working like it should be, and there is no problem in it. So I install it and secure it into its place. Now the fourth step in the repairing process, it was reinstalling the headphone jack into its place. As we can see, I reinstall it and secure it with a nut and with some adhesive paint. After I confirm that the headphone jack, it is secured into its place, I cleaned all of the buttons and all of the knobs in the unit, and also I cleaned the volume pot and the signal control pots and the tone control using some cleaning solution. Now what I'm going to do, I'm going to reinstall and resecure the front control panel, and then after that I will start the biasing procedure for this unit. So here is the unit, has been completely reassembled, and I resecure all of the covers into their places in the unit. And here is the front control plate has been installed and secure into its place in the unit with its holding screws. And now the amplifier circuitry inside of this unit, it is ready for the biasing process. Now the biasing process for this model, it is very tricky, and according to the service manual, it is going to take from 12 to 15 minutes for every channel in order so it can be set correctly. So what I'm going to do, I'm going to set the biasing for both channels off camera, and then I will discuss the biasing process for this unit afterward in detail. So the biasing has been set to both channels, and everything seems okay, and everything seems to be working fine. Now I'm going to walk you through how to do the biasing for this model. The first thing that you need to do is to make sure that the ambient temperature or your bench temperature or the surrounding temperature should be from 15 degrees to 13 degrees, and you have to protect the unit from a direct airflow. So if you have a running AC or a running fan, shut it off during the you have to shut it off during the calibration. The tools that you are going to need in order so you can calibrate the biasing for this unit successfully, you are going to need a DMM, an accurate DMM. It is preferable with a millivolt range, a vacuum tube voltmeter, or if you don't have one, a FET VUM will do the job just fine, and a frequency generator. Now, how do you start? Before you start, make sure that the power switch, it is in the off position. The volume, it is set to 0, and you have to make sure that the pots, the VR 500 2 and the VR501 and all and the other pots, they are set to the minimum because you don't want to blow up the output transistors or the driver transistors once you power on the unit. Now, after that has been said, you can start the calibration. Now, how do you start the calibration? You will start by connecting the probes of your DMM after setting the selector switch to the millivolt range, and you have to connect the positive probe of your DMM to the positive test point in the channel that you are going to calibrate, and the negative probe the same as I did. And then you have to flip the power switch of the unit to the on position. Once you flip it to the on position, you have to start calibrating the VR502, and that is for this channel. The 501, it is for this channel. But we are going to do the explanation on this channel, and the same steps it is applied to this channel as well. As I said, once you hit the power switch on, you have to start turning the pot until you get the reading on the DMM of a 3 millivolts plus or minus half a millivolt. Let it run for 3 minutes and then repeat the same adjustment until you get a reading on the DMM of a 5 millivolt, a plus or minus a 1 millivolt. Now the same step or the same steps or the same thing, it is applied to this channel without any change, except the position of the probes, because in this channel this is the positive test point and this is the negative test point. In this channel it is reversed. This is the positive test point and this is the negative test point. And this is the step 1 of the calibration. So after step 1 of the calibration it is done, you can proceed to step 2. Now in step 2 of the calibration, you have to start by connecting the FAT-VUM or your vacuum tube voltmeter probes to the speaker output of the channel that you are calibrating. And also you have to connect the frequency generator output to the CD input in the unit. But before you plug it in, and that is the frequency generator, make sure that the frequency generator, it is the frequency of it is set to a 1 kilohertz sine wave, and the output level it is set to 100 millivolt. After that, make sure that the CD it is selected from the signal selection circuitry. After that has been done, boost up the volume until you read 2 volts in the meter, and once you read 2 volts in the meter, start calibrating and turning the pot, and in this case for this channel it is the VR504, and in the other channel it is the VR503. Now once you start turning, you will notice that the reading on this meter it is going to be increased, and keep increasing the reading until you get a 50 millivolts, a plus or minus 5 millivolts. Let it run for 10 minutes and then you reset it and recalibrate the same pot until you get the reading of 60 millivolts plus or minus 5 millivolt. And after that, this channel, it is done. Now the same process, it is applied to the other channel, and with that has been done, your biasing, it is totally done. Now after the biasing procedure it is done, I'm going to connect the unit to the test gears in order so we can see what type of signal that this unit it is going to produce. So here's the unit has been connected to my test gears, and here's the oscilloscope has been connected to the load resistors, and the signal generator it is set to 1 kilohertz of sine wave and has been connected to the CD input of the unit. And now we are going to turn on the unit and we will see what we are going to get. So here we go. Here is the unit. It is turned on. Here is the protection relay kicked in, and that is really good. And now let's select the CD and let's slowly boost up the volume. Here we go. Here we go. Here we go. As we can see, everything looks very, very good, and we are getting around 30 volt point 87. So yeah, this is one of the channels, and let's switch the DMM to the other channel. Here we go, and let's repeat the same process. As we can see, the other channel it is behaving like the first channel, and that is really good. So if we calculate the what we get, a 30 volt point 87 multiply with 30 volt point 87 equals divided by 8, we are getting around a 119 watt of true RMS of power, and that is really, really good. So this unit it is working and working really, really well. Wow, I really like it. So let me connect some speaker to this unit and we will see what it does sound like. So I connected my speakers to the speaker terminals of the unit, and I already connected my music box to the CD input of the unit. And now let's turn the unit on and see what we are going to get. So here we go. Unit it is on. Let's hit play on the music box. Here we go. Select CD. And let's boost up the volume. Wow. Good God. Wow. Really, really, really strong. Wow. really nice. Let's try the tone control. There is the bass. The bass, it is working perfectly. There is treble. The treble, it is also working perfectly. Let's try the balance. The balance, it is also working perfectly. Wow, the unit, it is working really well, and it sounds really good and very strong. So yeah, I believe we have a perfectly working amplifier. Wow, that is really nice. So all what I have to do now is to put the back cover on and secure it with new screws, and I'm done. And this unit, it is ready to be delivered to the owner. So in the end, I hope you enjoyed this video. If you did, please like, subscribe. Thank you for watching. See you next time.